And so what we're taking a look at here at the start is this particular problem and looking to see, can we solve it? Well, things get a little bit interesting in this one because at first it looks like the same old thing, right? Where, okay, we can go ahead and add 8 to both sides, we can divide both sides by 2, all that kind of good stuff. When we do that, that gets us down to this point, but it's 3 to the power of x minus 1 equals 64. How do you undo the power of x minus 1?
X plus 1?
No, we can't do anything with x plus 1 because that x minus 1 is trapped inside the exponent. Technically roots do offer us a way to deal with exponents, but if we did that, we'd be having to take the x minus 1 root of both sides. That's kind of messed up. We don't want to go there. And so, let's see here. Can we divide? Well, it's not being multiplied, so we can't just divide it out. We actually end up having to have a new tool. There is a mathematical tool, there is a mathematical operation that exists solely for being able to figure out what does an exponent equal. And it's something that you've been seeing recently. It is a logarithm. Now, this is a problem from this point that, you know, within a week or two you'll be able to solve it, but not today. But I'm wanting to show you that the reason why we need logarithms, those logarithms that you were seeing yesterday pop up in problems, the reason why we have to know those is because it allows us to do a problem like this. Now again, you don't need to be writing this problem down because I'm not going to have you redoing this whole process here right now. But I do want you at least seeing that this is why we need logarithms. They let us solve for something in the exponent. So let's actually put this into our notes. And I'm going to have some more notes immediately to follow it as well. So into your notes, logarithms. Make it nice, big, easy to find later so that as you're flipping through your notes trying to figure out where you put that stuff about logarithms, you'll be able to find it. And write this down first, that the purpose of a logarithm is to solve for an exponent. So we know that logarithms then are used to solve for an exponent. So now the next thing is, how do we use a logarithm? In the work you saw yesterday, you're converting between log form and exponential form. This is the critical piece of information you need to know. If it's not already written down to your notes like this, write this into your notes now. So as you write down these notes, let's make sure you wrote it down correctly. Notice how we write this. This is a log, which we write like normal, log. But then this b here is what we call a subscript. It is written smaller and lower. Kind of like an exponent is written higher and smaller. This is written lower and smaller. So the b is not a full-size b. It's actually written a little bit smaller. And then the y is back to full size. Oftentimes when we do these types of problems, you'll see parentheses around the y. That doesn't change what it means or anything. It still equals the same thing there. And then the other thing I want to mention is making sure that you noted this down here, because we need to be able to speak the language of math here. And so when we read this, we read log little b y as log base b of y. So whatever this is, that's the base. And it's of whatever this number is. And of course we'll have numbers and letters and all sorts of things in those places as we practice going between these forms. And so in order to practice going between these forms, we're going to turn both of these exponentials into logarithms. And what makes them exponentials is the fact that we have something to the power of x or some other unknown. So we're going from exponential into logarithm, so that tells me I'm going from this form into this form. So the first thing I'm going to write then is I'm going to write log. And then notice the b is the thing that comes next as I write my logarithm. Notice where b comes from. B is the number in my exponential that's raised to some power.
10.
So in this case, notice the 5.
What
is being raised to some power. The 5 has an exponent attached to it. And so the 5 is my base, which I write smaller and lower.
Oh yeah, and then you put parentheses.
All right, next up is the y. Notice where y comes from. Y is what my exponential equals. That's the number that's by itself. It has nothing to do with the exponent part. Notice what's by itself here, the 10. And so the 10 is written next. Now again, as we write that 10, you can write it like that, or you can also put parentheses around the 10. Either way works. Although I will say that on WAMAP it's going to require the parentheses to be in there. But that's just because of the computer and how it understands things. We know it can go either way when we write it on paper.
So how do we write the 5 below?
And then last up, well, you could figure out what goes next just by process of elimination. I do want to see how we know. So notice the next thing we write there is the equal sign. And then it equals the x. Notice where x comes from. X is the exponent, which is actually really nice to know. And in this case, actually, x is my exponent here as well. But the way that I always remember, and the way I first started remembering how to convert between logarithm form and exponential form, is remembering that log always equals the exponent. So I already know that whatever the exponent is, that's going to be by itself when I write my logarithm. And the reason why is because that's why logarithms exist. It's to solve for an exponent. All right, now we repeat the same kind of process here for this second one. H to the m equals w. I'm writing it as a logarithm, so the first thing I write is log. Then the base. The base, remember that's the b, that's whatever is raised to a power. In this case, that is h. So I write a small, low h. And then that's of whatever's by itself.
W.
It's called y up above there. In this case, it's a w. And of course, log equals the exponent, so it equals m. And so that's your log form now. And once again, side note here, if you put parentheses around the w, that's fine, but you don't need them. Now, having done those last two, we can now go the other direction as well. So we're going to go from logarithm form into exponential form. So let's go and practice it with this first one. So I start with log base 2 of x equals 4. Okay, I'm going to go into now the b to the x equals y. So that means the first thing I'm going to write is the b value. B is the base. The base, remember, that's the small lower number. So in this case, that's the 2. So the first thing I write down is 2. Now as I take a look at my exponential, the x is the next thing, the exponent. Well, remember, log always equals the exponent, which makes it easier to find here. So that means it has to equal 4. Then the equal sign, and then the y value. Notice the y value is the full-size number that is put into log. In this case, that is x. And so that's our answer. And also you notice that in this case, that means that we happen to have been able to actually figure it out too. We could solve it based on having done that. Whereas that is an equation we have to solve. This is just something we can calculate. We could actually figure out what 2 to the 4th is. All right, now having done that one, practice it by doing the second problem. Write that as an exponential. And so for this one, once again, I do the base to the power of exponent. The base is n, and the exponent, remember log always equals the exponent, so it's n to the power of c.
Yeah.
Equals, well, process of elimination tells you what should be next, right? It's got to be a.
So how?
All right, for doing this one now, if you've got this pattern down, you probably can already kind of jump to the answer, but I want to visualize it here. And so in order to visualize it, I'm going to think of what would this look like as an exponential. Well, it'd be 9 to the power of x equals 81. Well, our natural reaction tends to be to say, oh, the answer must be 9, because 9 times 9 is 81. But remember, it's not 9 times x. It's 9 to the power of x. Well, if I multiply 9 by itself, that means I'd have 2 9s, right? So x would have to be 2. 9 squared is 81. And so you need to start by thinking about it as an exponential. But notice the cool thing about this is that we can then see that we can read a logarithm really as the base to the power of what equals this number. Or in other words, 9 to the power of what is 81 in this case. I want to repeat this process and get this idea ingrained in you so that you're comfortable using logarithms. So we're going to do 2 more sets of problems. And again, you should be able to do these without a calculator. All right, so we repeat the process now to solve these. So for that first one, if you can't just look at it and know, so like you're not automatic and just saying 5 to the power of what is 25, then by all means write it out first as an exponential, 5 to the power of x equals 25, because that visual is going to help you to solve it. And so we look at it and we say, okay, 5 to the power of what does give me 25? And remember, it's going to be 2 because it's an exponent here. All right, and then log base 8 of 8. It's saying 8 to the power of what is 8? Or in other words, 8 to the power of x equals 8. Well, what's the exponent if it equals the same thing? It's got to be 1. It tells us there is a single 8 in the problem. So 8 to the power of 1 is 8, so x equals 1. Last pair of problems that we're going to do together here. Go ahead and write down and do each of these now. All right, now as you go and do these, you notice what's different about these 2 problems from the previous ones is I don't have it equal to anything. Well, if it makes you feel better, you could actually write in equals x and you could go ahead and use it that way. It's going to work the same way. Or you could just say, well, remember I'm reading this as 2 to the power of what equals 8, and just be figuring that out. Now in this case, 2 to the power of what would equal 8, that means I got to multiply a bunch of 2's together to give me 8, so 2 times 2 is 4, times another 2 is 8. Okay, so notice how many 2's I had to multiply there. 3 of them. And so the answer is 3. 2 cubed is 8. All right, and then for the second one, well, again, you could write equals x or something like that if it helps you, or you could just go straight to 4 to the power of what equals 1. And in order to answer this problem, you'd have to remember anything to the power of what is 1.
It would be 4.
It would have to be 0. Anything to the power of 0 equals 1.